All right, so we have the final scores. Not much has kind of changed. The scores have changed slightly. So these are the final scores from the leaderboard, and the team at Temptation is kind of still the winners for round one. And then the winners for the community contribution prizes, and we very happily congratulate them and the rest of the teams who have their final scores right now. We would also again congratulate all the contributors to the community contribution prizes. They have been we were hugely overwhelmed and surprised by all the contribution that came in, and it was a hard job to kind of select who the final winners are. And if any of, as I mentioned, if any of you are here on this call, it would be really good to kind of have you kind of spend a few minutes walking through the notebook and just talking to the community in general. I will hand over to Brushank right now to whatever the other items in the agenda are after this particular announcement.
Okay. Thank you, Mohanty. So the new leaderboard is live, as well as we've announced the community prize winners. Congratulations to everyone. Now we'll move on to Guillaume. He'll take us through. He is one of the challenge organizers from Firmenich, and he'll take us through his PPT. Guillaume, you can take over. Great. Yeah, we can see you.
Okay, I share my screen. Okay, thank you guys. I will a little bit, let's say, talk about Firmenich. So basically, Firmenich make ingredients, fragrance, and flavors since 125 years. We are the first worldwide company in fragrance and flavor as a private company with more than $4 billion of dollar revenue this year. We are the top 3 worldwide company in this field. All our plants in the world, we have more than 20 plants in the world, in China, India, Brazil, several ones. All are 100% renewable power energy, and we are gender equity since a few years already. What we do at Firmenich, we make ingredients, we make formulas, and we sell it. What I want to say is when we use, for example, Lego, and those Lego are chemicals, generally you obtain this kind of, let's say, nothing very interesting mixture of ingredients. This is something that smells not very interesting, I will say. The job of a perfumer and flavorist is really to make such kind of good fragrances. So you have to really build something from these pieces, so from those chemicals. And it's why the challenge is very important for us, because we build ingredients, and those ingredients are the keys for making good perfume and flavors. Around 30-35% of all what you eat and smell in the world are built by Firmenich. And it's sold to our client, can be a big fine fragrance company, fine fragrance, or can be just a cream for the body or something for the toilet. Everything is a big part of it come from our company. And after 20 years of experiments, you are able, normally, if you are a master perfumer, to really make a fine fragrance. And it takes a very long time to do that. And it's why Firmenich is really proud to announce since last month that we are the first company in the world in the fine fragrance to have created the first formula by ER. It was a big journey for 2 years of research in our labs, sponsored by external, internal partner, also supported by Microsoft, and our client, for example, the research, the flavorist, and the perfumers that are all connected to this tool. I put there a few references of the work we published recently, especially one that is the second one that is really focused on go behind the 1D representation of molecules using transformers and showing that this information can be very useful, in fact, in terms of, let's say, in questioning the problem of 3D, questioning the problem of stereoisomers, and it may be some, let's say, information for you for this challenge in this paper. We also are very active in the retrosynthesis and synthesis prediction. We have a paper that will appear normally tomorrow in Nature Communication. And we are proud also, it was a fight with my company for almost 1 year to bring this challenge open, just to say, okay, guys, we have a data, we can build something very interesting. So it took me around 1 year before you see anything to have this challenge opened and to have, let's say, my legal team agreed on opening this. What is very interesting also is that we didn't, let's say, initially put a price for community, but Moiti and AIcrowd team start this initiative alone, and I think it's very very interesting because it's something that we are not thinking at the beginning, and creating a community is very important for me, and also I think for you, because you may come with something more interesting with partners. You will also have some, let's say, support of the others. So yes, the price for the moment are not so big, but we may, let's say, continue and make a second challenge after this one for sure. This is the first thing. And the second one is that we now start the second round, and we will explain you what are the changes, what are the new tasks and the new challenge. And if you have questions, you can always contact me for sure. So I'm the main partner for Firmenich on this challenge. I will not respond day or night, but I will really take care that you have a fast response as possible. So I let Moiti to take the talk now.
I think, Guillaume, it'd be good, right? Again, I think this is not as a part of the agenda, but given that we are here, it would be good for the participants and the community in general to hear a little bit, right, on these questions when you were working on these, the whole notion of forming a challenge, your experience on working on these problems, because many of them are kind of going through the same experience that you and your team have been kind of working on the same aspects, right? Because one thing
I will not discuss the internal research, but I will discuss the community
exactly, yeah.
Notebook I saw. And basically, I was let's say, very impressed by the idea around, because you almost cover every, let's say, basic, not basic, in fact, every possible benchmark you can find. This is something that is good. I mean that ever you look at the graph, vector of smile, conception, graphs. So I saw almost 6 or 7, even a kineme. I see almost all the benchmark possible. So it's a very good baseline. Of course, you see that with those benchmarks, you reach, let's say, a very low score. But it's really encouraging to say that the people are welcome to share their knowledge. And what I can already told you, and you will see on my papers, look at ensemble first, and look at augmentation. So this is my 2 big advice, because it's you need ensembles for sure, and you need also augmentation, because this data is quite difficult to tackle, and without augmentation you cannot do anything. And this is the 2 big let's say advice I will give you. And also in the second round, I will give you a big advice, but we will talk with Moiti more in detail after. But I will take the mic after, okay, for that.
All right. No, I see that exactly itself was very helpful, right? We don't want to talk about the internal research; they will come in due time on in papers. But just these broad ideas, right, from your thought, is some directions that you guys should kind of consider and explore is kind of encouraging. That's really good. But with ensembles, I will be careful because in the subsequent rounds, we will be collecting the code and executing it on the test set ourselves. So you would have some constraints in general on how big your ensembles can be. But that also makes it a good point, right? On
Yeah.
that we want ensembles which are actually usable, not huge ensembles which are unusable.
Exactly.
But that's good. We will be opening up the discussion in general for a broader set of questions. If you have any questions, please post them in chat or in the Q&A section. At the end of this talk, we will be kind of having a small panel discussion of something with like anyone who wants to kind of join in. But Brushank, I will let you kind of move forward with the agenda of the call.
Yep. So now we have some of the top participants who will come and who will present talks to the community. I'll first invite Alara. Hi, Alara, are you here? Great, great. So you can take the floor. You're on mute in case.
Oops, sorry about that.
Great,
Hi
great.
again.
Go on. Hi.
Hi, my name is Alara, and I work part-time as a data science / machine learning consultant, but I'm also a PhD student at Boğaziçi University in Istanbul. My research focuses on cognitive learning and robotics, and I had absolutely zero work or research experience in chemistry prior to this. So it's definitely been fun. I just randomly came across the competition on AIcrowd, and it seemed really fun, so I wanted to try it out. And in my opinion, people are usually intimidated by problems that require domain expertise. But the truth is there are so many tutorials, papers, and other resources online. So you can easily get an idea of what the problem is about. And that is what I did, really. Before I started coding, I read about the Smiles data format and learned about the notation. And this was all very new to me. But this helped me learn that even seemingly tiny differences can make a huge difference in how the molecules behave. So at first, before reading about that, I was planning on experimenting with language models or representing the molecules as images and using CNN, but I decided against these. Also, the data set is small, at least for now, and these approaches wouldn't make sense without some form of transfer learning. So I read a few papers and I saw that molecular fingerprints were quite popular. So I ended up converting the Smiles data to Morgan fingerprints. And in my understanding, molecular fingerprints are a bit like language models. They try to find a way, the optimal way to say, to screen and map molecules in a meaningful way. So after doing this, I just used a logistic regression model and with Morgan fingerprints as input. And that got me a 7th place ranking at the time. So that was pretty good. I also experimented with dense neural networks, but I found out that the models largely overfit when you use more than one hidden layer. So that was also really useful because I saw that the problem is not that complex. But I haven't experimented with other fingerprint types. And my biggest challenge personally was working with imbalanced and multi-label data. I used a very crude approach. I just treat it as a single label problem, and I got the top 15 labels and just ranked them. So it is probably not very optimal. I haven't explored any transfer learning. I haven't explored hierarchical classification. I haven't done any future engineering. So there are so many interesting directions to explore. So that has been my take so far.
Great. Thank you, Lara. Yeah, anything else do you want to add?
Not really. I think the problem is well stated, and I really had fun. So thank you.
Awesome. Awesome. So everyone, if you have any sort of question, okay, go on, Mohanty. Sorry.
Yeah, I was just adding one thing. Given that we have some participants giving a talk, I will throw in one series of questions, which would be, what is the one thing that you absolutely hated when you were taking part in the competition? It was really hard, you were like really irritated. And what is the one thing that you absolutely love? Just quick answers to both the questions will also help us improve your experience in the subsequent rounds.
Well,
Now I'm putting in the spotlight.
Okay, so the best part is the problem is so much fun, and it's just chemistry is so intimidating, at least to me. So it's what like tackling this problem really helped me break down some mental barriers. Like I found out that domain knowledge, not expertise, but some knowledge is not that difficult to gain. And I saw other people's community contributions, and somebody actually referenced a paper, and the writer of that paper, the professor, is working next door to my lab. So yeah, I don't know if that's cheating, but she's a really nice person, the professor, I mean. The worst part, I was and I'm still confused about the labels, because I don't really find them intuitive. When I did any kind of preliminary analysis, I was just looking at the labels and thinking what kind of odors might be paired together, as in like the multi-labels. But when I did the analysis, I realized that I was very far from the actual distribution of the data. So if I were to try hierarchical classification, I would need to look into that, but some kind of insight from the competition owners would be great.
Mm-hmm. Actually, those are two really good points. First, chemistry being intimidating. Well, that's a very subjective point of view. I personally had not been in touch with chemistry for quite some time. But when Guillaume's team actually sent us the data, I spent a few obsessed days, because I mostly work around a lot of reinforcement learning, deep learning stuff. And they sent across the data. I was like a little kid in a candy store. First, I was catching up on chemistry. Then I spent a few obsessed days where pretty much the team didn't see me, where I was working on training the initial baselines, and it was fun. Then I was trying to figure out how to translate that experience for the participants, right? So I'm glad actually you said that chemistry was intimidating, yet it was kind of a fun experience for you to take part. The second part is also interesting because I don't know, maybe Guillaume might want to talk about it later today, but in the subsequent rounds of the competition, we will be releasing the relations, at least some relationships that we know between the labels. And the idea is to kind of see how participants can use those labels to kind of come up with more meaningful training approaches and a few other such things. But thank you so much. That was really great. And I would also encourage other participants to come in and speak. These town halls are supposed to be more like, casual places where all the participants get to meet organizers and get to know each other, so on and so forth. I think we have to move on to the next talk. So Vishank, who's up next?
Next up, thank you, Lara. Next up, we have Shankar. Hi, Shankar. Shankar, you can take the floor.
Hi, first of all, thank you for having me here and this competition. A little bit about myself. I'm a computer engineer basically, and I used to work at the Bosch Center for Artificial Intelligence, and currently I'm a consultant with Ernst & Young for applied machine learning. So mostly on the technical side, not a very theoretical person with, let's say, chemistry or anything. But like from a young age, the guy who starts out with Arduinos and Raspberry Pis and sensors and stuff like that. That's how I started my, let's say, this hands-on experience. And at a young age, I started building this artificial doctor that I used to call him. Like, you speak to this device, you tell him that you have these symptoms, and it could tell you what is your disease. So this is my first kind of machine learning project that I ever built. So this is how my machine learning journey kind of started. And how did I come across this challenge? Like every week, I would just randomly search on Google for any ML-based competitions. Just every week, that's something I do. And I came across this learning to smell, because so far all the hackathons or challenges that I have attended were basically, let's say, classification or object detection or this mainstream based challenges. But this is the first time I thought like, okay, you're teaching a model how to smell. So this is completely new to me. And to be honest, this is also the first multi-label, multi-class classification problem that I ever worked. So it was pretty awesome for me to pick this up, and I found it really interesting. So that's how I started working on it, and it's been a very fun challenge to work on. How did I approach the problem? So maybe so yeah. So this is something I came across that Google had posted about how they use graph neural networks to teach machines to learn to smell. So I started off with the rudimentary, let's say, machine learning, where I just looked through the data set and I could identify that for each smell there's a base structure that's present. I'm not very keen on the chemistry terms, but then let's say that a particular compound has one molecule that contributes to the smell. So many of these compounds will have the similar molecule, and if this similar molecule is present, you could say that this is its smell. So based on that, I thought that you could go for a clustering technique, and I use the nearest neighbors, which fetched me around 38% accuracy. And then, like I guess almost all participants have also done this. You convert it into a picture and try to train it with the neural net. That didn't work out so well. I also tried to transfer learning, but the accuracy was pretty bad. I guess I'm missing out something in that region. So the other thing that I tried was obviously natural language processing. Like you guys have named it as a sentence, so it has some inkling to that, so right? For example, if in natural language processing, if you want to, let's say, predict the word spicy in this particular sentence, you say that the chili is dash in flavor. So you relate that the flavor and chili is somewhat in a correlation, and the word has to be spicy. So we could leverage this into this kind of compounds and say that if you have this particular molecule present in this compound, this could be the smell. So I tried that out also, like with LSTMs and RNNs, but I think I'm missing out something. So I got a very bad accuracy. So this is about 12%. But still, like these are the methods that I tried out, and it was really fun, like finding out that let's say deep neural networks are not the go-to, let's say, the method directly for data sets, especially that are small as this. Classical machine learning beats that pretty well. So that's something I learned, and yeah, like I would probably keep improving on it. And I feel that the answer lies somewhere in natural language processing. Let's see. Yeah. So yeah, that was mine.
Okay, great.
Right.
Shankar, thanks a lot. Yeah, go on.
I will basically open up the same questions again. Thanks for giving your perspective and your experience taking part. So, what is one thing that you absolutely loved while taking part in the competition, and one thing that you absolutely hated when taking part in the competition?
Well, I hated that this was a text-based, like it's a multi-label and text-based. So converting, so you have different methods of dealing with this kind of data. You do like TF-ID vectorization, or you convert it into some kind of one-hot encoding. This was a little like, usually I deal with data that already give you numbers, but this is like in text-based. So it's not something I hated, but it was a little, let's say, cumbersome. So that's all. And what I loved was, like I told you, this challenge is complete. Like you're teaching something how to smell. That challenge itself is pretty awesome that way.
I'm glad. And you said you started on multi-label and multi-class classification with this problem. Yeah? That's
this is
really
the first time I deal with such kind of data.
All right, that's good. Vishang, what do you have next in the agenda?
Awesome. Thank you, Shankar. So next we have Anish Jain. He's a computer science student from Central India. Welcome, Anish. You can take the floor.
Before that, I think if anyone is interested to kind of jump in and give an impromptu talk, again, you do not need slides. You just need to talk about your experience, some things you tried, ask some broad questions. Please let us know in the chat, or reach out to Vrishank or me, and we can promote you so that you can come in and give a talk. Now over to Anish.
Okay, hello everyone. This is Anish Jain. I'm from Satna, Madhya Pradesh. I'm doing this machine learning for about around 1 year. And how I know about this competition is one of my friend. Thanks to him, very thanks to him, which is Manidals, which is already in competition. He helped me about he talked about the AIcrowd is a good place to start something new. So I started from the AIcrowd. Actually, I'm doing Kaggle and Zindi competition also, but the competition, if you I know you also ask about the hate and the love part of of the AI crowd, so I can already tell you the best part here. The AI crowd, no, the problem statement which I found is extremely new for it's new. Okay, everywhere I just found okay the classification, text classification. So I always try BERT or the computer vision, transfer learning, ResNet. So this is all about a past four to 5 months of my journey with competition. But when I come into the AI crowd, I get extremely new kind of the first when I look at the data set, I don't know what should I apply. Either I have to apply computer vision, or I have to apply RNN, or I have to apply what I should apply. So that is the good part about the AI crowd. That's a big thumbs up. And now what I tried. Okay, let me clear what I tried here. Okay, uh, basically if I show you my collab, then I think it should be good.
Yeah, go ahead,
uh,
Anish. Go ahead. You can share your screen.
okay, okay, so where it is. So this is my collab where I just get started with this. So everyone is started with the RDKit method of converting smells into the vectors formats. But the basic problem which I find out there, the vectors which is coming out is huge first of all, and they are sparse vectors. It means most of the places where there zeros were there. But when I found this amazing GitHub repositories, he actually converting these molecules into some kind of vectors, which is a 300. The length of the each vector is about around 300, and this is a quite dense vector. So it is actually fastened my process of machine learning methods which I already applied with like XGBoost and all these things. And this is basic stuff which I downloaded like RDKits and all these other code, which is I think everyone out there tried. And this is data sets, and I just simple imports. And what I and also find out some of the labels were there, which is already two times present. Like in training ilog by 148 index, I found green, and there are so many other places. So what I this code is actually removing those two times, because maybe I think it 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 problem for the model. So I just remove those things first of all. So if anybody tried out with the labels, they can also see the labels for has problem with it, these kind of stuff. And then I tried with XGBoost. And why XGBoost? Because this is actually everyone because from whom I'm learning, they said machine learning, if you tried a machine learning approach, so always tried with XGBoost or random forest. So I tried with those, and this is I think a good thumb of rule to start with machine learning problems. So I started with XGBoost itself. Then these are the steps which is actually converting your smells into the vectors. And this is what and this is where I started with the XGBoost. Now the XGBoost has some problem. If the problem is there, we cannot classify a multi-label here. Okay, so for that reasons, I also imported from SQL. And there's also to convert any of the model which is only predicts the single label. We can also convert those into the multiple output classifiers. And how it works is basically it applies a single label. It applies XGBoost to each and every possible labels. So now we have 109 different unique labels. So it means this XGBoost has been applied to the 109 times. So of course that is a huge time taken. It takes too much time for me to train actually this XGBoost classifier. And this is and now this is actually, see, this is how many rows present in the training data set, which is 430, and the 3000 which I just created with it. Okay, and now which has 109 different unique labels were presented over there. And but XGBoost is amazing again good thing that is also supports the GPU now. So we can also use some power of GPU too, so maybe that's why some improvement in timing were also possible there. And now these parameters, and why I choose these parameters, these are the parameters which already work for me for the other competitions. So I just use them. But definitely people has to try with a great search, so I think they get more good results. Okay, and also train for the very small very little time. People can also try it with this. Okay, so this is a great search method. They can use it to get the more good results. So this is my basic approach, which gives me some kind of this accuracy, which is not good. But people can try a lot more other things. And this is my presentation, I think. But on the other side, I really wanted to I really think on the label side, people can also do one thing. Like we have a different kinds of label. We have fruit smell, we have alcoholic smells. There is also a relationship between all these smells. So if people can train those things, like smells, like on those particular labels, and train a model which actually gives a relationship between all these different labels. Like definitely there's a relationship between a fruity smells and the and maybe a woody smell, because they are quite same tune. So maybe this helps to improve our model. And definitely the one thing which is also found amazing, people can also try the graph neural networks, which let me share you guys the graph neural network, which is, I think, this repository which people can also mention this. I can also share with you. This is amazing repository from the MIT, which is I think done by some Google researcher. So where to start with it and all these steps. This is, I think, the graph neural network is a most important thing we can apply it, I think, in this problem. But people can try it. I won't have. I think I'm not able to do that, but people can try it, I think, with the graph neural network. I think this is done with me. So if anyone has question, they can ask.
Okay. Thank you so much, Anish. Mohanty, Guillaume, you raised your hand. Do you want to say something?
Yes, in fact, your idea of a label is something, in fact, that we will discuss just now, because it's part of the second round.
Yes, yep. I already discussed, I think.
It's but it's a very interesting idea. We talked about that a few weeks ago, and it's what we do now in the second round. Basically, we will ask you to find a way. So we will first give you some, let's say, initial relationship we know between the terms in olfaction. So, for example, we'll tell you that a rose is part of floral. Okay, this is obvious. You can find that in Wikipedia or any ontology. But based on that, what we want that you do is to find a way to try to compress the the label space to be able to improve the accuracy of the model, but not to compress too much. So we want that you find an optimal solution between increase of accuracy and compression of data. So, for example, in floral, maybe there is 6 or 7 flowers together. Should we keep them all, or should we just keep floral? And if we keep floral, is it bring better result, or if it's decrease both the details and not really improve accuracy? So this is the challenge of the second round. How you can find a way to optimize really your label categories versus your data compression.
So basically on this note, which I think I'm not getting you very much, but to improve, I think the graph neural network, which is I show you the PDF. They discuss about the graph neural networks because they know they learn the representations quite well as compared to the other machine learning model, like we have XGBoost. Because currently the decision tree, the random forest were the current state of the art for this particular challenge. I also tried with neural networks. I also tried with a computer vision problem, but they are not good enough because when we see the structures, they were not same. Some because we cannot apply transfer learning, or we cannot apply anything else, because they are not a kind of data which is already trained on. So definitely we should try it with a graph neural networks. I think this is maybe the state of the art the thing we get from the graph neural networks. This is my final words about how we can improve further on this particular problem set, I think.
A quick note though, actually, there's one trivia again. Maybe Guillaume wants to mention that, but one quick trivia is that Google recently filed a patent for using graph neural networks for figuring out smell of molecules. That's still a patent application, has not been verified, but then that's information out there. It's for you to basically read upon that and figure out how best to use that. But going back to Guillaume's point again, he was condensing a very important discussion that we were having, right, on how the future problem formulations would be like. And then I think we use the terminology we were using, so that might be the reason it might be a little bit confusing, but the key idea was simple. that we made many decisions for you when you were working on this problem, right? Because we already decided what is the vocabulary of words and whatnot, these 118 or I don't remember the exact number of vocabulary words.
Yeah,
But
100.
before we made that decision, we actually had the data set with about 170, 180 smell words, right? And we
Okay.
realized, given it's a long tail distribution, like in most real world data sets, that it might make sense to replace some of these really low frequency words with with some of their closest counterparts. So we basically take some of these labels out and replace them by another synonym of that particular word. That way we decided which of these labels to kind of include in the experimentation and which of these labels to exclude from the experimentation. Now we want to kind of enable you to be able to kind of make those decisions, right? Because much of research is about figuring out those problem formulation, where we will give you the whole data set and we will also kind of evaluate on the whole data set with these 170, 180 labels per se. And we'll also give you some relationship between these labels, and it's up to you to figure out how to efficiently map them into a larger ontology by whatever clever technique you can use. At one point, Shankar, I think, was mentioning on how you could actually take the language embeddings of these words and try to figure out which of them are related and how.
Yeah,
And you could
yes.
actually somehow condition that. Then you could also build up on this idea of enriching the ontology by looking at how the
Labels.
functional groups are kind of functional groups or any attributes are changing. But all those explorations would now be your decision, where you have to basically decide that these are the small set of labels that I will be making my predictions on, and we will figure out what your vocabulary is by simply taking a set of all the vocabulary words in your final prediction, knowing that okay, if you're not at all predicting a single vocabulary word across the whole thing, maybe it's not a part of your broader thing. We still have to figure out some fine details, but these are some rough ideas or hints around how the problem formulation will look like when we are moving towards round 2 and round 3.
Thank you
But
so. Definitely, I
yeah,
should
no
look
worries.
into it.
No worries.
Definitely, I
Again, we
should.
will be making those announcements, and I think I would want to kind of also Guillaume to talk about a little bit more, just the thought behind that problem formulation in general. But also, you did not mention what is the one thing that you absolutely loved about the competition, not about AIcrowd. AIcrowd is a broader community. We will talk about the competition in this case, and one thing that you kind of hated, right? Something we can definitely improve.
uh, Definitely the hate, I think it should not be the hate part, but the way we cannot in the I think AI crowd has, maybe I think that's the problem, because now AI crowd just maybe they started the discussion, because the discussion can be more good. I think we can, the more people, maybe this is not a problem of for this, I think, but people, maybe the people may join the more on the AI crowd. I think that can be solved out. But to find really good research for, like, in Kaggle, because I'm just coming from the Kaggle side, so
Mhm.
there is a lot of good discussion there. Okay, so we can already learn through a lot from those guys. So
Mhm.
definitely this can be the, maybe the hate part. I think, I don't know, this is a hateful, but this is can be the can be there if it is improved. And the love part about this small competition, because that is an entirely different competition. I already tell you, the RNN, I also always try. They are some kind of stuff that I always tried. Okay, I have just code for them. I have ResNet, I have to try it with FastAI. You have to try with BERT model for the, if there is an LP. So of course, definitely this is a different from me, and that is my, maybe the tough part about, because I learned something new out of it. And also some also sharpening my chemical my chemistry stuffs because I've been leaving
Mhm.
chemistry for, I think, last 2 years. So that is maybe the good part about it.
Mhm. Yeah, no, that's true. And yeah, that's one point we completely acknowledge, right? The discussions and the collaboration between participants is something we have been kind of trying to improve, because somehow all these competitions becomes too competitive, where people are very hesitant about sharing what they're working on or sharing ideas. That's why we have these explained by community contribution prizes and whatnot, to somehow seed these or incentivize people to start collaborating and sharing ideas. But I will also make another announcement about like a broader thing around how we operate in as communities and AI crowd and other things. That's where I will also kind of touch back on this notion of collaboration. Rushang, what do we have next on the agenda?
Okay, I think we're done with the participant talks. Now it is open flow. And if
Okay.
anybody wants to ask questions, and if you want to talk about the round two, or if Guillaume wants to talk about round two, I think we can talk about it now.
Mhm. Questions again we can take through the Q&A forum or the chat. For now, I would open if Guillaume has to kind of share any thoughts, ideas, or just anything about round two. Then I think before we end, I can take 1 or 2 minutes just to kind of make some other broader announcements.
Yes, so as Moati said, initially with my team, we decided to, let's say, simplify a little bit the problem, because basically you have very low frequency words. I call them words, but for you it's labels, to define and to describe olfactively a molecule. You can have only one word for all the 4,000 molecules, for example. But this word is linked to a closer word that is, let's say, more representative and more frequent in the database. So we decide manually, based on our knowledge, to make this process of grouping. And I think what should be done now, it's try to find a way using language machine processing, using ontology, using all the knowledge we can have, plus the information in Wikipedia about classical ontology of odors, finding an optimal grouping. When I say optimal, I have an idea here, because I don't want that at the end you have two classes. I don't know, flower and fruity. This is not what I want. At the end, what we are interesting is that you keep a certain diversity in the data set of label. So I don't want that at the end you come with 2, 20, 50 labels. I think maybe 80 is a good number, something like that. But the idea is we will measure, in fact, how if you compress, you increase your accuracy. So if your compression is very high and your accuracy is only jumped by 1 or 2%, this is wrong. If your accuracy jump by 10% and you just compress by 10% your data, you are in the good shape and you go to the right direction. So basically, we will add a way to also measure this type of, let's say, compression versus improvement. And it's very important for me because with too many labels, it's very difficult because we have a very small data set. I come back for one thing. Graph neural network is a very good tool, but it's not augmentable. Please read my papers about smile. Smiles are very augmentable, and you can really make a lot of things if you augment. In different tasks where we apply augmentation, we win between 10 to 20% accuracy without nothing else, just augmentation. Like in images, you can augment your smile representation by randomly shuffle the smile, the smile, let's say, order. And this is a tool that is that I myself put in RDKit a few years ago. Firmenich is active in open source. We are very active in RDKit. We in fact, all the 3D descriptor in RDKit was built by myself. So this is very important that you, for me, RDKit is one of the best tools that you can use. It's already connected to Python. You have all in your self-environment. I think the Mol2Vec example that we showed just before is an interesting also, let's say, idea of representation of the data, but it was trained on a specific task. And why 300, why not 400, why not 500 or 600 or whatever? And this is, you cannot use those fingerprint and thinking that, oh, I have a fingerprint, it will work like that, very easy for my task. So be careful, maybe to take just a fingerprint that you see either in GitHub or in a paper. You need at least either a transfer learning, either a pre-train or augmentation. This is really three things that you need to apply, and basically graph as is today is not augmentable. So it's limited to your size of the data, and it's something you will not obtain good result with it, I can tell you. If you compare the Google paper versus the DREAM challenge that was 3 years ago or 4 years ago, they Google win with graph less than 4% accuracy. So this is a very important point. They multiply by 10 the size of the data, and they win only 4% accuracy.
You could argue, again here, just to play the devil's advocate, just on that augmentation aspect, you could argue that when we are looking at, say, just smiles in the form of text per se, it's still kind of a low resolution version depending on what you are kind of looking at. But in context of a graph, basically the smile notation, which we are kind of, which is kind of a notation we are describing, and we are putting sequence of characters in a particular way. And in context of graphs, we are clearly defining these relationships. So you could argue that it's a high resolution version or representation of the same data, because you are representing as nodes and other things. So you need less data. So maybe augmentation itself is the necessity.
And we prove and we write
Okay.
in papers that augmentation with smile is better than graph.
Okay. All right. If you can empirically show that, again, that makes sense in general.
Yeah.
That's great. In interest of time, I think we will move on with the rest. The rest of the questions should still kind of come in, and they should come into the forums. I need that, and thank you, Guillaume, for sharing your thoughts and other things. We will be communicating with the participants with more details about the next round. But I wanted to also talk about this whole notion of this competition versus collaboration. So AIcrowd, again, as the whole platform, actually started as this side thingy I was doing. I started when I was doing my PhD, and my whole goal is to kind of build one giant research lab of sorts, right? It's not about running a bunch of competitions, but it's about figuring out how we gather a lot of people who come up with a lot of really interesting academic footprints, right? A few of the other projects that I started, they went on to become big. Like Flatland was, again, another project I started, was a small hobby project in the beginning. Then we ran it as a small competition. Then this year we ran it as a bigger competition at New Rips. And then we managed to gather a huge community of people who have been working around this particular problem. And that is something we want to kind of keep replicating across many of these interesting problems that we are working on. So in context of this problem, we already have a data set. We have amazing contributions from all of you with so many great solutions, alternate resources for people to get started on. But from an academic point of view, we will completely lose all the value as soon as the competition ends and you guys move on with everything. So one thing I personally really love to see happen, when throughout the course of the competitions, participants start kind of gathering together, not just to kind of win the cash prize at the end, where to ensure together can we leave a really good academic footprint, where there's so many of you trying so many different approaches with so many interesting variations. If at the end of it, we could somehow enable you to put everything together, and all of you together will have just one research paper in general that you can basically put forward. We already have partnerships with some publication houses who love to have these non-traditional competition research papers, where you take all these approaches together and do a complete exploration of all of these approaches, how they compare with each other. And it could also be a case where all of you kind of coordinate and prepare the final research paper, which basically goes, which are independently submitted to other conferences, journals, and whatnot. I would be happy to kind of start to kind of, put together an initial version of this in the form of, just the initial baselines that we train in-house, data set, problem description, so on and so forth. And if any of you are interested in contributing to the paper, I would suggest to start just a thread on the forums itself. And if any of you are interested in contributing to the paper, this is how we kind of coordinate. And a separate group of people can start talking on Discord or other channels to figure out the on-ground actions. But I would really love to see this whole thing also taking shape as an open research initiative, where there is a concentrated effort to not just win a competition, but gather multiple implementations of different solutions, and then all of them neatly clubbed together, a really good paper written exploring all these approaches in a coherent way, and hopefully giving a classic academic footprint to all of you who are putting in so much effort, time, and energy.
Yes, sir. On adding on your side, I just see the state of the art. I think they mention everything what happens in 2020. They also mention when the people releases their papers, they're only about 12% of the people they're releasing their codes. So actually, what you said, I think it's a good we can collaborate with everyone and just make something impactful. I think that's a good note that you have just tweeted.
I'm
Thank
glad.
you.
Yeah. I have a love-hate relationship with academia. I really like a lot of things, I dislike a lot of things, but things like ensuring that all the outputs that we create are kind of something which can be reusable across time, and truly open and reproducible research, all those things are not a priority. But I basically mentioned this open research idea as an apology in advance, because we will be enforcing an extra few steps on you, so that you will be, when you're submitting your code, to ensure that at the end of the competition all your code is reproducible. So this is, think of it as like an early apology when we announce all the approaches for how to submit your code for second round, which will be code and models. And Guillaume also mentions in chat that he will select the journal. That's really good. And that's pretty much it from our side. And I'm assuming this is the end of the webinar session, but
Yep.
it should not be the end of the conversation. The conversation should continue on the forums. Please feel free to reach out to me directly if you have any questions about the competition, or Guillaume, he mentioned that he would be happy to answer some of these questions. And that's an opportunity to keep shooting a lot of questions to Guillaume, because he has been thinking about these problems and working actively on this for quite some time. And I hope to see all of you in round 2 and also on the forums. Thank you so much for your time today, and congratulations to all the winners of round 1.
Thanks, Sharadan. Thanks for having us here. And yeah, let's see what happens in the second round. Thank you.
Thank you. Thank you,
Best
guys.
of luck,
Thank you so
everyone.
much.
Bye.
Bye bye. Thanks.
Bye. Bye. Bye.